All right, so today's lesson is on chapter 4. The chapter covers data, statistics, and probability. We're gonna look at different kinds of graphs, table, line, and circle graphs. We'll look at bar graphs as well. And then we'll cover frequency a little bit, and then we'll leave the rest for next week, the rest of the chapter for next week. Lesson 1 covers tables and pictographs, and the key ideas that the book conveys is tables and graphs are often used to display data, and you always want to read all the labels to understand what the data that you're being presented with is about, essentially. And then if there are symbols used in the graph, there's usually a key that you'll see on the side of the graph explaining what each of the symbols mean. Facts and information, and by analyzing data, we can make predictions or draw conclusions and solve problems. To be useful, data has to be organized in a certain way. And so a table essentially organizes data along columns and rows, and the labels in the table will help you understand what the data mean. Dealing with percentage increase, you calculate percent change by looking at the final value and subtracting that final value from the initial value, and then dividing that by the absolute value. So that's what these two bars outside of the word initial mean. They just represent the absolute value, and that just means that if you have a negative value, for example, you wouldn't put the negative value here. You would put its positive counterpart. So for example, if you had a value like -5, you wouldn't put down -5 here. You would put the positive value, which is 5. And so that's what this absolute value means, just in case you encounter a negative value. This divisor can't be negative when you're dealing with percentage increase. And then you simply multiply by 100. So again, for the formula for percent increase is the final value minus the initial over the absolute value of the initial times 100. And I mentioned in the last lecture that there's a formula sheet that will be available to you during the test. I don't know if you remember a few lessons ago, I mentioned kind of making your own little dictionary so you can write down, you can remember the types of, the different types of terminology that you'll encounter and even formulas that you use often. Well, there's actually a formula sheet that will be available to you during the test. But I noticed that actually the book also mentions that not all the formulas that you're likely to encounter, that you're likely to need, will be on that sheet. So what you would need to do is memorize those formulas. So I would maybe print out the formula sheet that the book has already started for you, and then add your own, knowing that those are the ones that you need to memorize and that the other ones that are on the sheet will be available to you on the test. So I don't remember seeing this formula on there, so it might be one that you need to add if it's not on there. So this example, the table shows population figures for select counties in 2000 and 2010, and the land area as well in square miles for each county. And so the question asks you, which county showed the greatest percent of increase in population from 2000 to 2010? So you would simply just start by looking at the information that you've been presented, right? We see Adams County started with a population of 11,128 in 2000, then jumped to 15,295 in 2010. And then you would just proceed, and quickly we can gauge that really only Adams and Davis County saw an increase between 2000 and 2010. As you can see, Bell County decreased from 25,199 to 22,707, right? So your first step would be just to look at the data look at the information being presented, and then determine which of your counties are actually showing an increase. Okay, and then once you've done that, you go ahead and analyze the data and use the data to then find the percentage increase. So since we've already predetermined that Adams and Davis County are the only two counties that showed an increase in population from 2000 to 2010, we can start with Adams County. And if we remember our formula, the percentage increase equals the final minus the initial over the initial times 100. So with Adams County, our final population in 2010 is 15,295. And we're going to subtract this final value from the initial, which is 11,128. And then we divide that by the initial, okay, and multiply by 100, which is what is done for you here. You can see that the percentage increase for Adams County is 0.374 times 100%, which gives us a percentage increase of 37%. And then you want to do the same thing for Davis County, right? Our final value was 90,834. We're going to subtract that from 82,204 and divide that by 82,204 and multiply by 100, which was done for you here. And you can see that this should give you 10.5 on the test. You would probably want to round this up to 11, right? Because when you multiply by 100, you're going to move your decimal point 2 places over to the right. So you would have 10.5. And since 5 is, remember our rule, if the number to the right is 5 or greater, we round up, right? And so since we have 5 here, we would round this 10 up to 11. So in case on your test you see an answer that's 11%, for example, know that they rounded this value up. So you can then gauge between your two percentage increases that you found, 37%, and I would say 11% in this case. And we can see that Adams County shows the greatest percentage increase in population from 2000 to 2010. Here's a test tip for you. The tables that you'll see will usually provide you a lot of information when you're answering a question. And you want to use only the information that's needed to answer the question. So for example, in this question about the population increase, we're given information about land area and square miles. But we didn't need this information to answer the question. And this is kind of similar to other scenarios that we've seen in previous chapters, where additional information that you don't necessarily need to answer the question is provided to you. And so you need to use your judgment in making sure that you're not using information that you don't need to answer the question. So a pictograph is another way to display data. And if you remember with our percentage rate formula, we saw a pictograph that had the part in the numerator, and then you had the base and the rate in the denominator. And if you needed to find the base, you would cover the base and you would have part divided by rate. So that was an example of a pictograph. And so it's essentially just a way to display data. The pictographs also use symbols to compare data. And there'll always be a key, like if you're dealing with a pictograph, there'll always be a key that lets you know what each value represents. So for example, if somebody was presenting that percentage rate pictograph to you for the first time, on maybe right next to that pictograph, they would tell you that P equals part and B equals base and R equals rate. So in this example, we're being told that a city has 3 public library branches and that a librarian kept track of the number of books checked out from each branch in a week. He used the data to create the pictograph below. And I'm not sure if you guys can see, I'll try to zoom in. So we can see that this little symbol for a book represents 150 books. So in this table, in the North Branch, for example, we see 1, 2, 3, 4, 5, 6, 7. So well, half the book means half 150, which is 75, right? So 150, 300, 600, 900, 975 books in the North. And you simply, all you would do is just add the number of symbols representing the book. So in this case, because we have 6 books, so can you guys hear me? I'm getting an internet connection is unstable notification.
Yes, you can.
Okay, good.
No, I can hear you.
Okay. So really you're gonna count 1, 2, 3, 4, 5, 6 times 150, right? Plus 75, because we have half a book here, right? And then you would do the same thing with the South. 1, 2, 3, 4 times 150 gives you 600, plus 75 books. Okay, same thing with the West. All right. So let's go back to the question. The question says, from March 4 to March 10, how many books were checked out from the South and West branches combined? So let's zoom back in. How many books were checked out from the South and West branches combined? So we start counting with the South. We have 1, 2, 3, 4 and a half first symbols representing books that were checked out. And then for the West, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so what will we do? We'll add 4.5 plus 9. Okay, and that gives us 13.5. And then we'll multiply that by 150 books, right? So again, since there are 4.5 symbols for the South branch and 9 symbols for the West branch, we're gonna add 4.5 plus 9, which gives us 13.5 symbols. And then to find the value of the symbols, you simply just multiply, since the key tells you that one symbol equals 150 books. I'm zooming in. Since one symbol equals 150 books, then 13.5 symbols times 150 equals 2,025 books, right? Which is the answer to our question. From March 4th to March 10, how many books were checked out? We can say that 2,025 books were checked out based on the symbolic representation that we were provided in the table. Okay. Do you guys have any questions before we go on?
Nope, not for me.
It's okay.
Okay. So again, same story, different day. Work on the practice exercises. So the next lesson is on bar graphs. A bar graph uses bars to represent numbers. So to find the value of a bar, you want to compare its length to the scale that's shown on one axis of the line. And an axis just means a line that's either horizontal or vertical, and we'll see that shortly. A double bar graph compares groups of data, and so you want to read the key to find the meaning of the bars. So when you're working with bar graphs, know that they use bars. Bar graphs use bars to represent values. And bar graphs will usually have two axis lines, of a vertical, which is usually called the y-axis, and a horizontal, which is usually referred to as the x-axis. Okay, and one line shows a number scale, and the other line would show labels for the bars. So what the bar is representing. So if, for example, in the previous scenario we saw with the books being borrowed from the library, one axis would show the number of books, and then the other axis would show north, south, was it the North Library, the South Library, West Library, what have you. Okay, so by comparing the length of a bar to the scale, you can then estimate what value the bar represents. So in this example, we're being told that a national corporation made a bar graph to show the number of discrimination complaints made by employees during a 6-year period. About how many more complaints were made in 2010 than in 2009? So let's zoom in. You can see this a little bit better. So you want to start by reading reading the label. So each, as we've already mentioned, each bar is going to represent the number of complaints made within the year, and the years are shown underneath each bar. And then, so the years are shown, this is the x-axis, and then the number of complaints are shown on the y-axis, or your vertical axis. So the question again is asking, how many more complaints were made in 2010 than in 2009? Well, we know that in 2009, the bar stops here, and so we follow that to the y-axis, and we see that 20 complaints were made in 2009. And then for 2010, the bar stops here, and so we follow that to the y-axis, and we can see, okay, maybe around 32. Here's where you need to use your judgment if it doesn't stop exactly on the line like it did for 2009, right? So you can kind of estimate. And we can say, okay, this looks like maybe it's around 32 complaints, okay? And so then you would simply analyze the data based on the information that you've been provided. We've compared the bars for 2009. We know that 20 complaints were submitted in 2009. And now we've determined that around 32 complaints were submitted for 2010. And so then you would simply just use that information to find out the difference, right? You would subtract 32 from 20, which is 12. And then you can confidently answer your question that there were about 12 more complaints in 2010 than there were in 2009. Okay. And so the bar, again, as mentioned earlier, just is a pictorial representation, or a way to use pictures to represent numerical information. Okay. Yeah, you may not be able to find the exact value of a bar. So if a bar falls halfway between two numbers on a scale, use a whole number that lies in between, right? Don't try to estimate it as 32.5, right? Because there's no way to actually ascertain that unless the divisions on the vertical axis are actually showing striations that tiny. Then you can obviously provide that level of detail. But this is just telling you that if you're in a situation where you have to estimate the value between two whole numbers, make sure that your estimate is also a whole number. So a double bar graph usually contains more than one type of data. right? And we'll see that in this example. We're being told that a studio released 4 films in 1 year, and that the graph below compares the cost of making each movie to its box office receipts or ticket sales. Film B's cost is what percent of its box office receipts. And so if we zoom in, we can see that this graph, the title will always tell you what the graph is about, right? So this bar graph is about a profit analysis for four different films, right? And for each film A, B, C, and D, we know we're provided information about the profit made in millions of dollars, right? So here 20 represents $20 million because it's telling you right here on the x-axis that these values are in millions of dollars. So this 140, for example, represents $140 million, okay? And so, so just keep that in mind. Because this is a pictorial representation, they're providing you with condensed information, right? So they're not going to write out 20 million here, right? Because it takes up space. But you should know from paying attention to the information that's provided along each axis that you're given, what's being told to you, or in this particular instance on the x-axis, the numerical value being represented by the figures that you're seeing. So this is the key that is letting us know what's going on with this particular bar graph, right? We know that the grayed out boxes represent box office receipts, or I should say the grayed out bars represent box office receipts, and the black bars represent the cost, right? So let's go back to our question. It says, what is the percent, what film B's cost is what percent of its box office receipts, right? So we've read the labels and the key to find out the meaning of the bars. We know that the grayed out bars represent the box office receipts, and the black bars represent the costs, right? And then I also drew your attention to the scale. I'm saying here that notice that the scale represents millions of dollars. And so a scale is just a contracted or a narrowed down version of an actual representation. I don't know if you remember in one of our examples, we were trying to figure out the distance, the actual distance, like if 1 inch represented 150 miles on your phone, how many miles do 5 inches represent in real life, right? So that 1 inch is a scaled down representation of reality, right? And so that's all a scale means. When you see the word scale, it's just letting you know that you're not dealing with the actual, or you're not looking at the actual figure. For example, here you're looking at 20, but it's not, in this particular instance, it's not representing 20, it's representing 20 million, right? And so the scale in this example is in millions. Okay, so we've noticed what the scale represents, and we know what our, and we've interpreted our key. So we have in our mind what our keys represent in terms of the information that we've been given. And then you just proceed to analyze the data. So looking at film B, we know that it cost around 30 million. And let's zoom in. This is film B, okay? So we could start with the box office receipts. We're in between 60 and 80, and this bar ends right here. So let's say that's around 65 million, okay? We're just guesstimating. And then this is the cost, and that the bar for cost ends right here for film B, and so we follow that to the x-axis, and we see that that's right in between 20 and 40, so we can estimate that that's around 30 million, right? So this is essentially telling us that it cost 30 million to make film B, and when the film was released, the film made around 65 million. Okay, let's use let's practice a little bit more and use film and look at film A. So we see that the cost bar ends right here. So we follow that down to the x-axis. That's, I don't know, around 80, 83, 84. Okay, 84 million. Well, let's go with 84 is the cost to make film A, and film A brought in, we're gonna go follow the top of the bar down to the x-axis, and we're looking at, say, around 130 million. Okay, and I'm doing this so that you understand that when it comes to these kinds of graphs, you kind of have a little bit of license to make a guess, but make sure that your guess is an educated one, right? So for example, looking at film A, if you follow the end of the bar graph to the x-axis, to the corresponding location on the x-axis, you don't want to say that this is 160, right? Because 160 would be out here, okay? But you do have a lot of room in between 100 and 120 and 140 to make your guess, okay? And we've looked at this, and in our minds, we've decided that the most accurate number would be maybe 130, since this falls right in between 120 and 140. Okay, so back to our question, we've decided that film B cost around 30 million to make, and it brought in 65 million in receipts. So what do? We divide 30 by 65, okay? And that would give you this decimal, multiplying that by 100% would give you 46%, okay? I'm trying to see if there's anything that I've left out. Do you guys have any questions?
No, I'm good.
Okay,
Yes, I
okay.
mean,
Yes, okay. All right, so more practice exercises.
I cannot see these pages in the book.
Yeah, because the page numbers in my book are different from what you guys have.
Okay, so we just follow after the text, we make the practice that comes after, right?
Exactly, yes, yes.
Okay. All right.
So now we're moving on to line graphs. So when you're working with a line graph, it's useful, it's good to know that line graphs are useful for showing changes over time. So by analyzing the rise and fall of the line, you can tell whether something is increasing, decreasing, or staying the same. And like a bar graph, a line graph has two axes, your y-axis or your vertical axis, and your x-axis, which is your horizontal axis. And one will be marked with the scale, like we saw in the previous example. Our scale was in millions, and so usually the scale will be axis, because when you're dealing with a line graph, and the time intervals will be shown on the x-axis, and then the information related to the graph, whatever you're looking at, will be on the y-axis. Okay, it just depends on the kind of graph. Okay, so maybe you want to, that's something else that you want to make a note of when you're making your little sheet. Like, okay, this is the kind of graph that I'm working with. Where will I see the scale, and where will I see the information related to the graph? Okay, and when we're talking about scale, we're talking about a numerical representation of reality that's been contracted to fit the graph. Okay, A line graph is useful for showing changes over time, as we've already mentioned. And so by analyzing the rise and fall of a line graph, you can tell whether something is increasing or decreasing or staying the same. And like a bar graph, a line graph will have two axes, your vertical or your y-axis, and then your horizontal or your x-axis. And one will be marked with the scale and the other will be marked in regular time intervals. Okay, so in this example, so this is what a line graph would look like. And in this example, we're being told that this graph is a representation of the number of patients who visited an emergency room for treatment of scooter-related injuries. And you can see here, the title will always tell you information or what the bar graph represents. So we see that this is a line. The title will tell you what, in this case, the line graph represents. We see that this line graph is one for West Side Hospital, and it's showing us the number of emergency room visits related to scooter injuries. And so the question is asking us, in which month did the greatest increase in scooter-related injuries occur? Well, let's zoom in. So with this question, you could be tricked to looking at this because the highest point, so each point here has a numerical representation on the y-axis or vertical axis for the number of ER visits, right? So you could be tricked into thinking, since this point has the highest, or this dot represents the highest point compared to all the other points that we can see here. You can see that these dots are just connected, right? So you may be tricked to giving September as your answer, but notice what the question is asking you. It's asking you, in which month did the greatest increase in scooter-related injuries occur? Now, when you see the term increase, that usually tells you that you started with something small and then you ended with something a little bit larger, right? So we should be looking at two different points, right? We shouldn't be looking at just the single peak here, or the highest point on our graph. We should be looking at two different points. And so one trick that I use to help me remember if the graph is increasing or decreasing is if you picture this as a mountain that you're climbing, right? If you're going in this direction, you're making progress up the mountain, but when you reach the top or the zenith, and you start moving in this direction, you're going downwards, right? And then you get here and you see that you're moving sort of, it's not as large of an increase as, say, this, for example, but you can see that you would need to be stepping upwards. And so this also represents an increase, okay? So with that, as top to bottom, your line is decreasing. But I think it's a lot easier to just imagine yourself kind of walking up a mountain, and you can determine in your own mind that if you needed to go from May to June, so these 2 points right here, it would be the equivalent of you walking upwards, right? Same thing would be true for here and here and here, but from this point to this point would be the equivalent of you walking downwards, and this point would be the equivalent of you walking upwards, okay? And so again, we're asked, in which month did the greatest increase in the scooter-related injuries occur? And again, if you remember what I told you about the word increase, it means that we're moving from one point to, one initial value that's lower to the next value that's a lot larger, right? And so the points on the graph are positioned above the months These are the months that you see here marked out on the x-axis. And they're arranged in calendar order as well. So we see May, June, July, August, September, October, November. And then by examining the line that connects the points, you can tell whether there was an increase or a decrease from one month to the next. So the steeper the line, the greater the increase. And so this is another thing that you have to remember when you're looking at line graphs, is that you're going to have to be able to determine how steep a line is. Well, the other thing that I use to kind of make that determination is let's say that you were at this point on your mountain climb and you're looking to the next point, right? You can determine that this is going to be a pretty steep climb for you. It's not going to be as easy as, say, maybe climbing from here to here, or even from here to here, where the line is a lot flatter, right? So the angle or the angle of the line determines its steepness. So in this case, if we're making our judgment and we're that mountain climber, we would say that it would, the line between July and August would be the most difficult for us to climb if we were making an assessment, right? Because it would be a lot easier for you to slip when you're in this portion of your climb than, let's say, when you're here, okay? Because the line between July and August is the steepest, and because the line between July and August is also showing an increase, we know that we can answer a question by saying that the greatest increase in scooter-related injuries happened between July and August. Okay, and this is just simply telling us that between July and August, we can actually just do the math by following the dots, right? We can see, let's say this is around 27, and this is right at 80. So 27 minus 80 is 53. Follow this dot at 80. This is right at around 100 and let's say 105 minus 80 is 25. So you immediately know that 53 is greater than 25, right? So essentially, this graph is telling us that between July and August, the hospital had 53 visits that were related to scooter injuries, but between August and September, the hospital, had about 25 or 23, whatever that number was that we determined, right? But instead of having to do all that math, you can just look at the pictograph. You can just look at the line graph, and you can make the determination from the line graph, okay? And we know just from looking at the way that the line is angled and the direction of the line, we know that the period between July and August saw the most injury-related reports, okay? And that's the word that I was trying to think of earlier, direction, right? So if the line is moving upwards, sloping upwards from left to right, we say that the line is increasing. And if the direction of the line is sloping downwards, we say that the line is decreasing, okay? So again, I think it's just a lot easier to imagine yourself climbing a mountain. What direction would you be stepping if you had to go this from here to here? Well, you would be stepping upwards, right? So you would be increasing. What direction would you be stepping if you had to go from here to here? You would need to step downwards, right? So that means that line is decreasing. And then how difficult to compare steepness, right? Or to see which of these lines is greatest, you would just make a determination concerning steepness, right? And so we've determined that we're most likely to slip when we're going this way just because the line is so steep. And so we know that this represents the greatest increase, okay? Do you guys have any questions?
Nope.
Okay.
Okay.
So if a line graph has more than one line, there'll be a key to let you know what the lines represent. That's the case for this example, right? We see that the graph shows changes in ticket prices for 2 amusement parks. So there, we can look at let me zoom in. We can look at the title of our graph, and it's telling us that we're comparing admissions prices. You can know immediately when you see this comparison of admissions prices, you know that the prices are about the same type of information, or the prices concern the same type of information. In this case, it's park admissions, right? So we see that our solid line here represents Park A, and our dashed line represents Park B. We see the dates in years on the x-axis or on our horizontal axis, and on the y or the vertical axis, we see the price, the ticket prices, okay? And so the question asks you, what was the last year in which the admission price to Park B was greater than the admission price to Park A? And so we see here the word greater gives us a clue about what we should be looking for. Remember in the last example, we saw the word increase. And so immediately we know in our mind that for something to increase, it has to start small and then get bigger, right? And so we looked for something that represented an increase on the line graph, right? And again, in this particular example, we're being asked, and what was the last year in which the admission price to Park B was greater than the admission price to Park A? Well, okay, let's start by looking at Park A. And we see that, let me zoom in. We see that in 2005, if we follow this location on the graph, 2005 to the first point on Park A, and then we follow that point to the y-axis, we see that maybe that's around, I don't know, guys, what do you think, 19? Okay, maybe 18 or 19. So let's go with 18. So we can say that in 2005, the price to enter Park A was $18, okay? Then in 2006, if we follow this point on our x-axis to the corresponding point on Park line graph, and then we follow that point to the y-axis, we can see that maybe that's around 22. So we know that our price has gone from $18 in 2005 to around $22 in 2006. Then we can move over to 2007, and we follow that point over, and we can say that maybe around 2007, in 2007, the ticket price increased from 22 to around 27. Find out where the two lines meet each other, and that's right here. And this point tells you that both parks were charging the same amount around this time. So let's say this looks like it would be around maybe March of 2007, going towards 2008. Both parks were charging around $28, okay? So whenever you're dealing with line graphs and you see that both graphs touch at a certain point, it means that that's representing an equal value, okay? And so if we go back to our question, it's asking us, what was the last year in which the admission price to Park B was greater than the admission price to Park A? So when you're looking at this graph, you should keep in mind that whichever line is on top will be greater. Why? Because it will represent the larger numbers. So for example, from this point onwards, we can see that point A has the point A, excuse me, Park A is on top of Park B. And that just simply means that its corresponding values on the y-axis will be greater than those of Park B, and we can check that. Okay, let's go to 2008. We see that Park B is, let me zoom in. Right here for 2008, Park B, the admission prices were, let's say, around $29, okay? And then 2009, we see around the same, 29. And then in 2010, exactly on the line for 30, okay? But if we compare that to Park A in 2008, we see that the line for, the price for admission was around 35 in 2008. And then in 2009, it was around 39. And then in 2010, it was around 46, okay? But so all those numbers or all those ticket prices that I mentioned for Park A are a lot larger than the prices that we determined for Park B, right? And it just makes sense. The line is higher on the graph, which is equivalent to saying that those values represented by the line will be higher, right? But if you look on the other side of the graph where they both meet, so on the left side, you can see that the reverse is true, right? In 2005, the admissions price to Park A, $19, okay? In 2006, let's say around 22. In 2007, we can say around, I don't know, 27, okay? But then if you look at Park B, we can see that those prices are actually higher, right? In 2005, let's say around 25, okay? And then 2006, also 25, and then 2007, maybe around 29, okay? But you can see that changes after both graphs meet right here. On the right-hand side, we see now these prices are much lower, where we started off with Park B being higher than Park A, so representing prices, of course. And then we see that at this point where they meet, the prices for Park B are now lower and the prices for Park A are higher, okay? So with these kinds of graphs, it's really just a matter of you using your judgment or your intuition and just asking yourself, okay, which graph is higher? Starting in 2005, it looks like Park B, right? Because it's right above Park A. And then around this point, they both meet, and then there's a change. We see that Park B is now lower and Park A is higher. And so that gives us a clue as to how we can answer our question. And if we read the question again, it's asking us, what was the last year in which the admission price to Park B was greater than the admission price to Park A? And so we can go back to our graph. And we can see that that is around 2007. Okay. The admission prices for Park A are represented by a solid line, as we've discussed. And then Park B's prices are shown with a dotted line. The graph begins in 2005 for both, right? We can see that both graphs have values right above 2005, so they both begin in 2005. Park's B ticket price is greater than Park A, and we determine that by just looking at the location of the graph. We determine that since Park B's graph is higher than Park A's graph, then the prices for Park B must be higher than the prices for Park A, right? So we're just using logical reasoning here, okay? So then you want to follow the two lines to the right, as I showed you earlier, right? We followed the lines. We went from 2005 to 2006, and we gauged the prices, and then we moved and we continued, right? And then we noticed that between 2007 and 2008, the lines meet, or the lines cross, right? And so we determined that we said that where the lines cross means that that's the point where both parks were charging the same amount. In this case, around maybe $29, okay? And then we know that beyond that point, the behavior of the lines start to change, and we see that all of a sudden, Park A starts charging more money, and Park B maybe heard that Park A is now charging more and they want to attract more customers, so they start charging less money. Okay. And so we can determine based on the behavior of the line graphs that the year where the last time that Park B charged more than Park A was around 2007. Okay. And again, for this particular example, you wouldn't want to say 2008. Why? Because this point where the lines meet is closer to 2007 than it is to 2008, right? So if you think of these, the distance between 2007 and 2008 as months, if you were in if you were in March of 2007, you wouldn't say that it's almost New Year, right? But if you were in December of 2000, or if you were in November of 2007, you could say that it's almost 2008, right? So with this picture, that logic also makes sense, right? Since we're closer to 2007, we can say, you can see that if I zoom in, this point where the two graphs meet, if you follow that line down to the x-axis, it's not exactly sitting on 2007, is it? But logically, we can see that because this point is closer to 2007 than it is to 2008, or even 2009 or 2010, or any of the other years, we can determine that 2007 is a valid answer for this question. Okay. Do you guys have any questions?
No.
Okay. So again, with line graphs, again, just pay it the key thing to remember is to pay attention to the behavior of the graph. Okay. If you see two lines that meet, you know that the point where they meet represents equal values. And then you want to look at the behavior of the graphs before they meet and after they meet, okay? And then you also want to look at the location of the line graph. So after the meeting point, the line graph of part A is higher than the line graph for part B. And so we know that the prices for part A after the meeting point are higher, the prices for part A rather, are higher than the prices for part B. Before the graphs meet, and we look at the behavior of the line graphs, we can see that the location of the line for part A is below the line for part B. And so we know that the prices for part A are lower than the prices for part B, okay? So again, just I guess walk yourself through, just kind of think logically about what it is that you are trying to figure out. And if, for example, this question became one about which year showed the greatest increase, right? Again, you would imagine yourself walking along this mountain, right? And at what point here are you most likely to slip, right? Or where's the line steepest? And the line is steepest right here, right? So we could answer that between 2007 and 2008, Part A had the greatest price increase, but then for Part B, again, we're walking along our mountain. It's fairly easy right here, right? Because the line is flat, right? And then maybe we have to step it up a little bit because you can see that the line kind of starts to slope very slightly, right? But then it goes back to being almost flat, and then again, kind of starts to slope, but very slightly. And so we can make a determination which line is steeper between this 2006 and 2007 and this line 2009 and 2010. So yeah, just keep that in mind when you're looking at these graphs. It's telling you a lot of information just based on the behavior of the lines, okay? Yeah, so note from the book is that the steepest line always shows the greatest increase or decrease, but it may not show the greatest percent of change. And so when you see the word change, I mean, when you hear the word change ordinarily, you know that something was a certain way and then its state was altered and it became something different, right? So change should immediately tell you that you're going from one point to the other, okay? And that would involve some kind of subtraction or a change in direction, depending on what the question is asking you, right? So just know that when you see that word change, pay attention to how you're answering the question. You don't want to give an answer that's only looking at one point on the graph. Know that you've gone from point A to point B, and you should be looking at what's going on between point A and point B, not looking at what's happening at point B, okay? And if I could go back to this example where I was telling you that it would have been easy to say, oh, September is the highest point, right? Or shows the highest number of visits. So you might put down, you might even see September as an answer choice, and that would be wrong, right? Because this question is asking you when did the greatest increase occur? And we know from our everyday knowledge that for something to increase, it has to start from a smaller point and then move to a greater point, right? And so to determine increase, like that note is telling us, you look at the steepness of the line, okay? The steeper the line, the greater the increase. The flatter the line, the smaller the increase. And you can think of it just in terms of, you know, a horizontal line that you're walking across, you expend less energy, right? when the ground is flat, because it's easier, right? But when it's steep and you have to climb a ramp, for example, now you got to use your muscles. You might start breathing a little bit harder. That's costing you more, right? That's a greater increase in energy, right? So if you think about it in that terms, I think it might make it a little bit easier to make a determination in terms of what you're looking at. But essentially, you want to make sure that you're paying attention to the direction of the line. So if the line is increasing, again, we're going up the mountain, you know that the line is increasing, okay? And if this sloping downwards, when we're going down the mountain, you know that the line is decreasing or your value is decreasing, okay? And then the angle of the slant will tell you the amount of increase, right? So you might consider this 0, and then if you've ever used a protractor, maybe this is like 18 degrees, so that's larger than 0, right? And then maybe this is like 45 degrees, and that's larger than 18, and it's also larger than 0, right? And so as the angle or the steepness of your line increases, so does the value, okay? And then you also, like I said, so there are two things that you're paying attention to when you're looking at a line. You're looking at how flat is it laying to the ground, right? Because the higher it is from the ground, the steeper it is, right? And the greater that value is. And you can consider the ground as 0, right? So when that line is moving from 0, it's getting larger. It's the value of that line is increasing, right? And then, but it's increasing in what direction? Is it going from 0 to 100, or is it going from 100 to 0? Okay, so you got to look at the direction of the line. If it's sloping downwards, as we discussed, going down the mountain, then you know that that line is decreasing downwards. If it's sloping upwards, you're going up your mountain, and that line is increasing, okay? And then the angle will tell you the amount of the increase, all right? And the more, again, the more you look at these, the more obvious it becomes, but it will require some effort on your part to practice, do the practice problems. So yeah, I'll just read this again. The steepest line always shows the greatest increase or decrease, but it may not show you the greatest percentage of change. So when the original value is small, a small change may represent a high percent of change. And we saw that when we were dealing with decimals, right? We saw that when we divided a small decimal by a whole number, we got a number that was higher, right? Like, so if you, for example, if you divide 0.25 by 1, you would get 4, right? If you think of 0.25 as quarters and that 1 as $1, how many times can 25 cents go into $1? 4 times, right? Because if you have 4 quarters, you have $1. And this is referring to the formula that we saw earlier on percentage change, where we started with an initial value. Excuse me, we started with the final value that we subtracted from the initial value, and then we divided that by the initial value to get the percentage change. Okay, and don't worry, all you have to do is write down that formula. So when you see percent change, you know exactly what's being asked of you. And then you just look into the question, what number were you given first, or what year was first, like maybe 2000, maybe in the example we saw, we were comparing 2000 with 2010, okay? Or if a value is mentioned first and then another value. Don't get nervous about this, okay? Just know that the clues are always in the question, okay? And it's just a matter of you recognizing the clue that the question is giving you. In this case, the question would mention percent of change, and you would know, oh, I need to use the percent of change formula that we saw earlier in the lesson, okay? If the question mentioned greatest increase, we know that to increase, you have to start small and go to a larger state. And then you would just look at the information on the graph. Well, you know, where did we start small? Where did we get bigger? And then compare the behavior of the lines to make your determination, as we've just learned how to do, okay? So what am I trying to say? There's no reason to be nervous. Just the question will always contain clues to the answer. Okay. So yeah, more practice questions on 753 to 755, but just know that you need to work whatever comes right after lesson 2. Okay. Are you guys okay?
Okay.
Yeah, I'm fine.
Okay. So lesson 3 deals with circle graphs. And if you remember, we've kind of seen this, we've seen this already. I think it was in chapter 1. Was it chapter 1 or I think it was chapter 2, where we were dealing with fractions and we were looking at pies, right? So that was an example of a circle graph. So a circle graph is used to show how a whole amount is broken into its parts. The sections of a circle graph are often labeled with percentages, okay? The size of each section corresponds to the fraction that it represents. So for example, a section labeled 25% is equal to a quarter of a circle. And this is where our lesson on decimal equivalence becomes important, because we know that 25%, if we drop the percentage sign and we move the decimal point over to the left 2 places, 25% represents or is equal to 0.25. That's its decimal equivalent. And we know from that chart of known equivalencies that 0.25 is the decimal equivalent of 1/4, 1/4. Okay, and this is just telling you that in the event that you saw a circle with only one part, like a circle that's divided into 4, but only one of those 4 divisions is shaded in gray, that 1 out of 4 represents a quarter of a circle, of the circle, but it also represents 25% of the circle, or 0.25 of the whole circle, okay? Excuse me. So in a circle graph, the circle represents the whole amount and the sections represent parts of the whole. The sections are usually labeled with percentages, but they can also show amounts. And then the size of each section of a circle is equal to the fraction or the percent it represents, okay? And that's just the same thing that we discussed just now, is that if we had a circle divided into 4 parts and only one of the 4 parts was graded out, that part represents the part that's gray represents 1 out of 4, or a quarter of the circle, and it also represents 25% of the circle, or 0.25 of the whole circle, okay? Depending on how you want to present that information, but you're just saying the same thing 3 different ways, right? You're saying that only one of the 4 circles is grayed out, or a quarter, so you're in that situation, you would be representing that information as a fraction. If you say that 25% of the circle is grayed out, again, we're still just talking about one part out of 4, which is 25% of the circle is grayed out. And in that scenario, you would be representing the information about that circle in percentage form. Or you could say that 0.25 of that whole circle is grayed out. And in that scenario, you would be representing the information about that circle in decimal form, okay? And that's all that this statement is saying here, that the size of each circle, that the size of each section of a circle graph is equal to the fraction or the percentage that it represents, okay? Or even its decimal equivalent. But we know that percentages and decimal equivalents, they're like twins, right? So if you see 0.25, you know that that means 25%. And if you see 25%, you know that that means 0.25, okay? But it also means 1/4. And yeah, so in this example, we're being told that the graph below shows how a children's sports camp spends its weekly budget. Okay, and so just like the other graphs that we've seen, we can see the title of the graph is telling us what's going on. So sports camp weekly budget 2,250. And this is where it's important to always read the title, because as you can see, this amount, 2,250, is not mentioned in the question, okay? And you'll see why this amount is going to be important to us in a little bit. But whenever you're given a graph, always read all the information that's provided to you about the graph. So if this graph had a key, you would see the darkest dot representing permits, and then you would see the next darkest, which would be this one, representing lunches. So there would be a key here, right? And you would want to read that. If you were looking at a graph that had axes, you want to read all the information on the axis, the y-axis and the x-axis. Read all the information on the graph, every single thing that you can see on the graph first, okay? And then go back to your question. All right, so it's asking you, how much does the sports camp send on lunches how much does the sports camp spend on lunches each week? All right, so again, the title is telling us that this circle graph is a representation of the sports camp's weekly budget, which is 2,225. 2,250, sorry. And of that budget, 2,250, every week, the camp spends, let me zoom in. Every week, the camp spends 28% on bus. So maybe that's buying gas or, fixing a tire or whatever. It spends 8% on permits. Maybe they have to park somewhere that requires a fee, okay? The camp spends 11% on umpires, okay? Maybe those are checks or something. 35% on lunches, and then 18% on equipment, okay? So immediately we know that this circle represents this amount, 2,250. And then each partition or each part represents how much of that circle is going to whatever event or whatever task, whatever you want to call it, that is assigned to each part, okay? So let's go back to the question. How much does the sports camp spend on lunches each week? So we go back to our graph, and we can see that this is the portion of the circle that represents lunches and showing 35%, okay? And again, if we're thinking of this in terms of a pie, okay, 35% just means 35 out of 100. So percent meaning a whole, right? So 35% meaning that 35 parts out of the whole, which can be represented by 100, goes to lunches, 35%. Okay, so in order to figure out how much the camp spends on lunches, the dollar equivalent of this 35%, all we need to do is drop the percentage sign, okay? And then we're gonna move our decimal point 2 places over to the left to get our decimal equivalent of 35%, okay? And we know immediately after those steps, after dropping the percentage sign and moving our decimal point over to the left 2 times, we know that 0.35 is the decimal equivalent of 35%, and we can simply multiply 0.35 by this amount here, okay? And that's why I was telling you earlier that you should always pay attention to the title and all the information provided to you about the graph, because if you notice, the question doesn't tell you that the sports camp's weekly budget is $2,250, but you see that here in the title, okay? So again, if we go back to our definition of a pictograph, it's a very condensed way of representing information, right? So know that everything that you see when you're looking at a graph of any kind is information, right? And you need to pay attention to what? All of that information. We also defined earlier in the lesson that data is information. So graphs are a pictorial representation of information, right? So you want to make sure that you're paying attention to what? All the information that's being given to you by the graph, right? So, excuse me, again, analyze the graph, and according to the heading, we see that the entire circle represents the camp's weekly budget of $2,250. So then you find the section labeled lunches, and we've done that. We know that this is the section labeled lunches. And according to the section label, lunches make up what? 35% of this entire budget of this entire circle that represents our budget, right? And so then you just use that information that you have from the graph to answer the question. We know that we're spending 35% on lunches, and our entire budget is $2,250. And so to find 35% of $2,250, we drop our percentage sign, move the decimal point over 2 places to the left, and we know that 0.35 times 2,250 is 800. I'm getting tired. $787.50. And so you know that that is the amount that the camp is spending every week on lunches, and that $787.50 is coming out of this budget of $2,250. Okay. So again, this circle is a representation of what? The entire budget. And the different parts of the circle tell you how much of the budget in percentages, how much of the budget is going towards a certain activity or a certain task, okay? And then if you're asked to find the dollar equivalent, all you would need to do is change the percentage to a decimal form and then multiply that by the original amount, or and the original amount always represents that whole, right? So in our example, where we were talking about 25 cents to a dollar, the dollar represents our whole, and our circle would have been divided into 4 equal parts, each part representing 25 cents, and each part representing a small part of that whole, right? And so here we see the same thing, but just on a larger what scale, right? We see that Instead of $1, we're dealing with $2,250. And we said earlier in the lesson that a scale is just a magnified representation of a smaller, a magnified representation of reality, right? But in graphical form that you can easily recognize, right? And so here we're not dealing with $1, we're dealing with $2,250, and that's being divided into different parts here. They're not equal, but we know that each of these parts has a dollar representation. And when you add up each part, you should get $2,250, okay? And so essentially this question is asking you, of this $2,250, which is being represented by this entire circle, how much are we spending on lunches? Well, it's this portion right here. Grays, it's shown to us in this sort of light gray color. Is it light gray? Whatever color that is. They all look gray except for this. And this is white, but you know what I mean, right? Lunches are represented by this grayed out portion here. And so what do? We simply just drop the percentage sign, move our decimal point 2 places over to the left to get our decimal equivalent of 35%, which is 0.35. And then we multiply that by $2,250, and that tells you how much you're spending towards lunches. Okay, and this would be no different if let's say your boss gave you $50 and your boss says, use 35% of that to buy stationery for the office. Okay, what are you going to do? How do you figure out what 35% of 50 is? You just drop your percentage sign, move the decimal point 2 places over to the left, and then you're going to multiply 0.35 by 50. Okay, and then whatever you get is the amount that you need to spend on stationery. Okay, and so that's the same concept being applied here to find out how much we spent on lunches. We found the decimal equivalent of our percentage of the whole, okay, of the whole budget, and then we just multiplied that by the whole budget to get the amount, which is in this case $787.50. A circle graph may also be labeled using fractions or decimals. And we discussed that earlier in terms of our circle that was divided into 4 parts. And I mentioned, if you remember, that 1/4 is equal to 0.25, which is equal to 25%. It's just 3 different ways of representing the same information. Okay, and so one common kind of circle graph labels each section in cents to show how a dollar is used. Okay. So here's a test tip for you. Since a circle graph represents a whole or 100%, then amounts can easily be converted to percents. And that's what I tried to illustrate earlier. So for example, 0.05 on a circle graph could also represent 5%. So if you think of 0.05 within a circle that's representing a dollar, then 0.05 would be 5 cents or 5% of the circle, or 5/100 of the circle, 5 parts out of 100 of the circle. Okay, all different ways of saying the same thing. So according to this graph, what percentage of the average energy bill is spent on drying clothes, lighting, and heating water? Okay, so let's zoom in, and we start by reading the title of the graph. I don't know if you can see this. Let me move. Okay. So where do your energy dollars go, right? And we have a circle representing our energy dollars. This portion of the circle here, excuse me, represents heating and air conditioning, okay? And that's about 60 cents that we're spending on heating and air conditioning. This portion of the circle represents water heating, around 17 cents. Okay, then cooking and refrigeration, this portion right here. So turning on your stove, putting stuff in the fridge, it's going to cost you around 11 cents. Then drying clothes costs around 3 cents. Other costs around 4 cents. And then lighting, turning on the lights, costs around 5 cents. Okay, and the question is asking you, what percent of the average energy bill is spent on drying clothes, lighting, and heating water? So we want to go back to our chart, and we know that we're being asked about drying clothes, whereas lighting and heating water right here. So what are we going to do? We're just going to add those costs together, right? 0.03, excuse me, plus 0.05 plus 0.17. That's 0.25 or 25 cents, right? So the book is telling here, first you want to analyze the graph. The entire circle represents $1. And then the amounts in the sections mentioned in the problem, and as we established, right? 0.3, we're spending about 3 cents on drying clothes, 0.5, about 5 cents on lighting, and then 17 cents on water heating. And then you just simply want to add, right? Determine that that was around 25 cents that we're spending, or 25% of $1 is the average bill that's spent, is the average of amount on a bill that's spent on these items, okay? You could maybe think of this in terms of your own, I don't know, budget or energy bill, okay? Sometimes when you get your energy bill, you'll see graphs. Sometimes mine, excuse me, mine shows bar charts. They're sometimes called histograms. So mine shows bar charts. Yours might show a circle like this, and it's just telling you how much you're spending on heating or on energy for certain portions of your house, right? And so if you wanted to find out, well, how much am I spending? Let's say your energy bill was $1, okay? Like in this example, how much am I spending on drying clothes, lighting, and water heating? Those are the only 3 things I'm interested in, because maybe you know that for whatever reason, that particular month, you washed more clothes than usual, you forgot to turn the lights off at night, and you drank a lot of hot cocoa, I don't know, right? So you want to determine how much energy went towards those activities that month. Well, you would simply just add, right? So again, it's just a matter of understanding the question, figuring out what the question is asking you, and then trying to make a personal application if it helps you to get a better understanding of the question, and then using the information that's provided to you on the graph to answer the question, okay? So more practice questions, and we have one more lesson. Are you guys good? Do you want to take a break?
I'm fine.
Yeah, okay. France, what about you?
I'm okay. You can
Okay.
continue.
All right, so this is our last lesson for today, so hang tight, we're almost there. And this one is on measures of central tendency. So let me zoom in. A frequency table is used to show how often data occurs. And then you'll see tally marks that are made next to a list of records. And I'm sure you've seen them before, but we'll see examples in this lesson. And then numerical data is often grouped into intervals. So for example, when we were looking at how much Park A and Park B were charging, we saw how the year was grouped into intervals for, I think it was starting from 2005, and then yearly intervals until 2014 or whatever, I don't remember. And then we saw equal intervals also on the horizontal axis that represented the prices, right? And so that's what this is trying to tell you here, that the numerical data is often grouped into intervals, and that those intervals are usually equal, right? So in terms of the x-axis where we saw years, we saw that they were only 1 year apart. Sometimes you'll see the spacing is 5 years apart, but they'll always be equal. And you're not going to see like 5 years and then 2 months and then a week. Like you would never see that. Okay, that would be an incorrectly spaced interval. Okay, and that doesn't occur on graphs presenting you data that you need to make inferences about, okay, or judgment calls on. Like the intervals will always be equally spaced, okay? And that's all this is telling you here, that the numerical data is often grouped in intervals, and those intervals represent equally spaced quantities or measurements, right? So again, you wouldn't see 2005 to 2006, and then January to February, and then Thursday to Friday, okay? You would see either years, or you would see months in the correct order, or you would see days of the week in the correct order, or dollar values, maybe in terms of 5, 10, 15, 20. Okay, so the intervals in that case is 5, or you would see 10, 20, 30, 40. So the intervals in that case would be 10. Okay, so they'll always be equally spaced. And that's what an interval means. It's just spacing between from one point to the next. So when you're using a frequency table, you want keep in mind that that a frequency table shows you how often an item appears in a data set. And the data is always presented in forms of tally marks next to a list of items. So here is an example of a frequency table that's presenting us information using tally marks, okay? So every time you see a line going through the tally, you know that that immediately represents 5, okay? And if you don't see a line going through, like for in this example, you would just count the number of tallies, in this case 1, 2. Right, so for each tally where there's a line going through, we know that that number indicates 5, and we can count, simply count 1, 2, 3, 4. The line going through is the 5th, okay? So this question is asking, or this example is telling us that the sales manager at Montana Motors asked her sales staff to keep a record of the color of the cars that were chosen for test drivers in 1 month. Then she combined the data to make the frequency table shown below. So let's go back here. for every white card she saw, she would make a tally mark. And then until she had 5, with the 5th one being represented by a line going through the 4 tallies that she made, okay? So in this particular instance, she saw 1, 2, 3, 4, 5, 6. 6 times 5 is 30. She saw 30 white cards. In this particular instance, we have for black, we have 1, 2, 3, 4, 5. 5 times 5 is 25 plus 1, 2. So she saw 25 plus 2 or 27 black cards. Okay. And you would just read the rest of the tallies the same. So for red cards, she saw 1, 2, 3. 3 times 5 is 15. So she saw 15 red cards. For green, 1, 2. 2 times 5 is 10 plus 1, 11. So she saw 11 green cards. For silver, she saw 5, 1 plus 1, 2, 3, 4. 5 plus 4 is 9. So she saw 9 silver cards. And then for other, maybe like orange and other colors that are not specified here, she would put a tally mark down each time, and across a line across for the 5th car each time. So 1, 2, 3. 3 times 5 is 15 plus 1 is 16. She saw 16 cars that were not these colors listed here. Okay. And so the question is asking you, what was the ratio of black cars driven to silver cars? And if you remember our lesson on ratio, whatever is mentioned before 2 is going to be your numerator, okay? Or you want to pay attention to the order in which the information is mentioned. So black cars are mentioned first, right? So we're going to go back to our tally. And we're going to count 1, 2, 3, 4, 5. We know that 5 times 5 is 25, but then we see 2 extra tallies here, 1, 2. So we know that the 25 plus 2 is 27. We know that she saw 27 black cars, okay? And the question is asking us, what is the ratio of black cars to silver cars? So we go back to our chart and we look for silver is right here. We see the first 5 counted for us. And then 1, 2, 3, 4. We know that 5 plus 4 is 9. She saw 9 silver cars. Again, the question is asking you for the ratio of black 27 to silver cars. So you're going to write down 27 to 9, or 27 over 9. Okay. And again, this is where the order of information becomes important, because in this particular instance, you wouldn't want to write down 9 over 27, okay? Because that would be the incorrect order. You would be answering a question about silver cars to black cars in that scenario, if you had written down 9 over 27, okay? But this question is asking us, what was the ratio of black cars to silver cars? So we're going to write down the number of black cars first, which is 27, to the number of silver cars, which is 9. And then if we go back to our lesson on fractions, we know that this is a top-heavy fraction. Why? Because 27 is greater than 9, or the numerator is greater than the denominator. So what do we need to do? We need to reduce this fraction to its lowest terms, right? And if you started studying your table of multiplication, you know that 9 goes into 27 3 times, right? 9 times 3 is 27. So to reduce this fraction, you would divide the bottom by 9 9 divided by 9 is 1. 9 divided by 27 is 3. And so now we have a ratio of 3 to 1, as reflected by our fraction 3 over 1. Now we have our ratio 3 to 1. And we would say that the ratio of black to silver is 3 to 1. Okay. Or you can say that the black cars are 3 times more popular than the silver cars. So in other words, for every 3 black cars, she would see 1 silver car. So like every time 3 black cars pass by, the next car that passed by would be silver. Okay, that's essentially what we found here. And so again, that goes back to the order of paying attention to the order that the information was presented in, because if you had written 9 over 3 and you said that your ratio was 1 to 3, then you would be reporting that for every black car, she saw 3 silver cars, which is incorrect. Okay. So the correct order of the cars that she saw passing by was that for every or the correct ratio is that for every 3 cars that passed by, for every 3 black cars that passed by, she saw 1 silver car. Okay. And so that we've answered our question, what was the ratio of black cars to silver cars? We went to our tally. We counted the number of black cars. Again, we know from memory that every time you see tally marks and then 1 line crossing through, you know that bundle, if you want to consider it, that represents 5. So we counted our tally marks for the black car. We saw that we had 27. We counted our tally marks for the silver car, and we saw that we had 9. But then we had to determine what order to put our ratio in. So we go back to the question. The question mentions black first. So we're going to write down the equivalent number of black cars, which is 27, and then followed by the number of silver cars, which is 9. Okay, and then from our lesson on fractions, we know that this is a top-heavy fraction that we need to reduce to its lowest terms. In this case, that happens to be 3 over 1. So we can say that the ratio of black to silver cars is 3 to 1, or you can think of it in terms of how many cars she saw how many black cars she saw moving past her for every silver car. So you could think of this 3 to 1 as, or you could restate it as saying that for every 3 black cars that she saw passing by, she would see 1 silver car. Okay. Numerical data is often grouped in intervals, as I was trying to explain to you earlier. So the table that follows is going to show data that's grouped in intervals of 18 to 24 to 25, from 18 to 24, and then from 25 to 40, and so on. So this way of representing data is called a grouped frequency table. Okay, and we'll see why in a little bit. Okay, so if several problems refer to a frequency table, you may want to count the tally marks for each line and then record the numbers on the wipe-off board. I don't know if you guys go into the center, the physical GED center, but it's essentially saying if you're dealing with frequencies and you're counting tally marks, physically write down the tally marks on the wipe-off board that's provided at the center, and then use the numbers to solve any problems or answer any questions that would be related. This is here where we mentioned that we're going to be looking at a grouped frequency table. in intervals of 18 to 24, and then 25 to 40, and so on. This is the table that that is being referenced there. Okay, and so in this example, the table shows the ages of customers at Louise's Diner for a 4-day period. Excuse me. What percent of the customers were from 25 to 40 years old, right? So we start off looking at our table, we read the title, it tells us that this table is providing us information about Louise's Diner based on the number of customers put into certain age groups, okay? Between February 19th and February 22nd, or a 4-day period. Okay, so for customers under 18, she saw 5 plus 1, or 6. So between February 19th and February 22nd, Louise's Diner saw 6 customers that were under the age of 18. Okay. Then between the same time period, she saw 1, 2, 3. We know that 5 times 3 is 15, plus 1, 2, 3. 15 plus 3 is 18, or she saw 18 customers between the ages of 18 and 24. Okay. And I should make a note here that I had to, I don't know if you can see, like there's a white space here. I had to cover, I think the book made a mistake with this particular tally. So I just covered the information and put the correct tally, just so I mentioned that in case you're working on the example in the book and you come across and you see that this isn't showing 18, it's because I changed the information so that it could actually be correct based on the question, okay? So again, for the age group between 25 and 40, Louise's Diner saw 1, 2, 3, 4, 5. 5 times 5 is 25, plus 3, 28 people between the ages of 25 and 40, okay? And then for the age group between 41 and 55, the diner saw 5 plus 5, which is 10. So they saw 10 people in this age range. And then for over 55, they saw 5 plus 1, 2, 3, which is 8. Okay, they saw eight individuals who were over the age of 55. All right. So going back to just the point about intervals, here you're seeing, so between 18 to 24, that's a 6-year difference. Between 25 to 40, that's a 15-year difference. Between 41 to 55, that's a 9 plus 5, 14-year difference. But we're dealing with the same concept, or with the same measure. And in this case, it's an age range, right? So for example, we don't see under 18 to 25, and then 5,000 apples, right? Or 5,000 dogs, right? And I just wanted to point that out so that you don't get tripped up on the fact that the distance between the ages are different. So that goes back to the comment that I made earlier in tonight's lesson, that you know, for each particular graph that you're working with, try to pay attention to how intervals are presented, okay? Because for a frequency, the space between your intervals will be different, and that's exactly why we need this tally, because we're trying to figure out, okay, well, between 18 and 24, how many people did we see? Well, we just use our tallies, right? But if we were looking at a line graph, okay, the ages would be spaced out in such a way that you would be able to say, okay, for people that are 24 years old, we would be able to match that exactly to the number of individuals that we saw, which maybe we saw 30 people that were 24, right? So the intervals would be different on a line graph, right? And I'm just saying that so that you can be aware, and so that you don't get tripped up when you're dealing with the different kinds of graphs, or the different kinds of pictograms that we've worked with this evening, okay? The point I'm trying to make is that they all present information in different ways, and you should pay attention to how information is being presented to you, okay? So this question is asking us to find the percentage of customers that are from 25 to 40 years old, right? And we've already counted here, we know that that percentage, the number of customers is 1, 2, 3, 4, 5. 5 times 5 is 25 plus 3, 28, okay? And then we need to figure out percentage based on the total number of customers, okay? So again, we started by figuring out that there are 28 marks that represent this age range, right? Based on the information that's being presented. And then the next step we need to do is find the number of individuals represented for the remaining age ranges, okay? So go to your under 18, we see that the number of customers is 5 plus 1, which is 6. So you would write down, that's where the 6 comes from. And then for your age group between 18 and 24, we know that the number of customers is 18, okay? And that's why I was telling you earlier that I had to change this information because the number of tally marks here was incorrect. So just pay attention to that if you're working on this example in the book and you notice that it's the wrong number of tally marks. Don't get tripped up, just count it correctly based on the information, okay? So for the 18 and 24 group, we know that there are 18 total tally marks. We've already established the total tally marks for the 25 and 40 group, which is 28. For the 41 to 55 age group, we know that there were 10 total customers. Excuse me. And then for the over 55s, we know that there are 8, okay, as shown here. And so you simply just add the total number of customers that they saw within that time period. And then you go ahead and divide or find the percentage by dividing your part by the whole, right? So our part in this case was 28, which represents the number of customers that are in the age group between 25 and 40. And our whole represents the total number of customers that they saw within that time period, within that 3-day time period, 19, 20, 4-day, I don't know why it's saying 3. It should be a 4-day period here, but yeah, can you see? It's like I guess this is an editing issue because here we have a 4. Oh, I see. Okay, I think this 3-day period is referencing no, that doesn't make sense because like we don't know what days this group of people came in. We just know that they saw this group of people spread out over this 4-day period, right? So anyway, you would find the percentage by dividing the part by the whole. And we know that the part is 28 based on the number of tally marks next to our 25 to 40 age group. And we got our whole how? By adding all the tally marks, okay? So 28 divided by 70, you can reduce that to 4/10. And you know that 4/10 is the fractional equivalent of 0.4. And then you would, to change that 0.4 to percentage, you would multiply 0.4 by 100%, and that would give you 40%. Okay. And this is just if another way of thinking about this question would be, let's say that you own a store, okay? And you're trying to figure out how many people between the age group of 25 and 40 came to your store within a 4-day period, okay? And so you would start by finding the part, which is the number of people between the age of 25 and 40 that came to your store. In this particular example, it's 28 divided by the whole. So again, in this particular example, you would be thinking about the number of people that came into your store within that 4-day period. Why? Because those 28 people are a part of a larger number of people that came into your store within a 4-day period. And so that's why we're dividing here 28 by 70 to get the percentage. Okay. Is this clear, or is there something that you want me to maybe
It's clear.
Yeah, okay. Excuse me. All right, so again, so once you have your part over your whole, remember our lecture on fractions, or excuse me, on percentages. You have your part over your whole, or your fraction, your fractional representation. To get your percentage, you simply reduce your fraction to its lowest terms, okay? And then convert it to its decimal equivalent. Remember, so for example, we established that 1/4 was the fractional equivalent of 0.25, right? Which was the decimal equivalent of 25%, right? 3 different ways of saying the same thing. But this question is asking us what percent. So we can't leave our answer in this form, even though technically it's correct. But because the answer is the question is asking you to express your answer in terms of percentage, you need to go further. And you would do that by first reducing your fraction to its lowest form. And once you've done that, you transform the lowest form of your fraction into its decimal equivalent, which in this case is 0.4. And then you simply want to multiply by 100%. And if you remember from our lesson on percentages, 0.4 times 100% simply means 100 over 100, okay? If I said 50%, that means 50 over 100, okay? So per, remember we talked about per being that representing this division line that we're looking at here, and then cent being derived from the French word centime, right? So if I tell you 100%, you know that I'm saying 100 over 100, okay? So we move our decimal point 2 places over to the right to indicate that we've multiplied by 100, because again, remember, 4 times 0.4, excuse me, times 100 is the same as moving the decimal point over to the right 2 times, okay? Or 40. 0.4 times 100 is 40, or you can simply put it into your calculator. There's a percentage, and I actually I realized that I actually have the calculator, but this one is very, very old. It's from a standardized test that I took many, many years ago. So this one is really old, but the buttons are pretty similar. And you would see here that right above the open parentheses right here, right above the open parentheses is your second function fraction. I don't know if you can see that, but you can see, I said second function fraction, but I meant second function percentage. So right above your open parentheses, and right above it, if you didn't want to figure out what 0.4 the percentage equivalent of 0.4 is, you would just simply press your you would enter 0.4 using the keys here. So here's 0 point, here's 4. Okay, so enter 0.4, then press your second function key, and then press this right here to take you to the equivalent, and you would see your answer being displayed on your right hand side as 40%. Okay, so that's just another way, but it's good for you to work through these and recognize the fractional equivalents, so that in the event that you make a mistake, you can check yourself, things like that. So you should know, try to memorize try to memorize that table of decimal equivalents and their corresponding fractions. But then just also know that you can use your calculator. Once you found the decimal, find its fractional equivalent, or you can just simply move the decimal point over 2 places to the right and then add your percentage sign. Okay. Yeah, so that's essentially it for today's lesson. Oh, sorry. There's one more section on mean, the median, and the mode. How are you guys doing? I'm getting tired, as you can see. Are you guys okay?
Can postpone for
I'm
next.
hanging in there.
Okay, what was that, friends?
We can postpone if you're tired.
Oh no. Yeah, I don't want to hold you guys back, so I definitely have to keep going. All right,
Okay.
so this session is on the mean, median, and the mode. And so suppose that you were asked how much money you usually spend on groceries in 1 week. Okay, in some weeks maybe you spend a lot. Okay, and then other weeks you might spend much less, and that's normal, right? So you would probably choose an amount that's in the middle, like let's say one of your friends is asking you, how much you spend on groceries every week. And in your head, that it changes from week to week. But, to give your friend an accurate answer, you would choose an amount that's right in between what you spend to represent the average value. Okay. And so that average value is called a measure of central tendency. All right. And it just means, you simply know what central means, and you tend to either spend more or less depending on the situation, right? So your tendency is your propensity or your predisposition to spend more or less depending on the situation. In this case, it's groceries. So your tendency to spend on groceries depends on, I don't know, what you have in your fridge. Okay. So you would tell your friend a number that's in between your high and your low value, or your high spending and your low spending, to give an accurate representation of the average amount you spend or your central tendency. Okay. The most common type of average is called the mean, or the arithmetic average. And we'll see that in examples that follow. So in this scenario, we're being told that there are 5 football games and a team has scored 14, 21, 3, 20, and 10 points. okay? What is the mean or average score per game? Well, we know that each game they scored a different point. For the first game, they scored 14. For the second game, they scored 21. The third game, they scored 3 points. The fourth game, they scored 20 points. And for the fifth game, they scored 10 points. Well, if you said, let's say that you were talking to a billionaire, you're the team manager, you own the team, and you're talking to a billionaire that wants to buy the team. And you told that billionaire, well, you know, they always win 21 games, have legal problems because you misrepresented, right? So in order to accurately represent the number of team wins so that you can be telling that potential client the truth, you would add the number of games that the number of wins per game. So 14 plus 21 plus 3 plus 20 plus 10. And then you would divide that number, which in this case is, you would divide that sum, I should say, which in this case is 68, by the number of games that your team played, which is 5, as told to us in the question, okay? So 68, put that in your calculator, 68 divided by 5 gives you 13.6 points per game. So then you can tell that investor, oh, my team on average, they win 13.6 points per game, okay? And so as the book tells us, even though it's impossible to score 13.6 points in a football game, that average represents the central score, or the measure of central tendency, or the mean, or the arithmetic average of scores for the 5 games. And I'm using those words or those terms interchangeably so that you can know that if your test mentions mean, central tendency, arithmetic average, you know what you need to do. You need to add all the scores that you have and then divide by the number of scores that you have, okay? In this case, the number of scores that we have was 5, okay? And then if you look back at our scores that we have, we've determined that our average is 13.6, right? And so that's kind of close to 14, okay? And then 21, well, it's not greater than, it's not an exaggeration, okay? It's not greater than 21, okay? So we're still kind of okay in terms of giving an estimate, right? Like, so if we, I don't know, if we think of this in terms of dollars, okay, and we said that how much do you spend every day on coffee? Let's say you've determined that the average that you spend is 13. We can see, okay, on day 1 you spent 14. Okay, yeah, that's kind of close. On day 20, on day 2 you spent 21. Okay, that's a little bit higher than the average. So maybe on that day you were really tired and you needed some extra coffee. Okay, so on day 2, you spent higher than your average amount. You spent $21 when usually you spend around $13, okay? $13.60. On day 3, you spent only $3. Maybe you didn't, maybe you just asked for a shot of espresso, okay? And that cost you just $3, okay? On day 4, you were tired, but you weren't as tired as day 2. Okay, so you spent $20, all right, which is a little higher than your average of $13. And then on day 10, you spent, excuse me, on day 5, you spent $10, okay, which is lower than your average, but still within range. Okay, so what are we doing here? We're saying that when you go to your favorite coffee shop, you know that you need at least $13.60. Sometimes you might need more, sometimes you might need less, but if you have $13.60, you're at least guaranteed to get a cup of coffee, okay? So essentially, that's what the mean or the average is representing, is what's that central value, or what's that average value that will always make sure that you're in the ballpark of the figures that you're looking at, okay? That you're not over, that you're not exaggerating your team's wins, but then you're not also underrepresenting your team's wins. Because you don't want to tell that billionaire that, oh, your team only wins 3, right? Because then he might be like, well, you know, I don't want to buy your team, you know. And you don't want to tell that investor that your team always wins 21, because then when his lawyers investigate, they might find out, oh, you were exaggerating, and then you might lose that deal, right? But if you tell that investor that your team wins on average 13.6, then that investor can determine, okay, is that a number that I'm comfortable with? Is 13.6 high enough for me, or is it too low? They can make the decision, but at least you gave them information that was mathematically correct, okay? So that's all an average is. It's just a numerical value that mathematically is representing the central tendency, or the mean of several values that are being considered or that are being compared to each other, okay? So a calculator would be useful in this case, because, you know, as we saw, all we had to do was add all the scores and then divide. So you always want to make sure that you count after you've added all your scores, you then count the number of individual scores that you have, in this case 5, right? So in this example, if this question hadn't told us that they played 5 football games, we could simply just count 1, 2, 3, 4, 5, knowing that each score represented a game, right? That was the end result of one game, right? So you would add all your points that were scored together, 14 plus 21 plus 3 plus 20 plus 10, and then divide by what? The number of games, okay? Which in this case is 5. They tell us in the question, but if the question doesn't tell you, you just know that you need to count the number of scores that you have, the number of individual scores, and that's going to be your what? Denominator, okay? So this is just telling you all you would do is enter the addition operation, so add your scores, and then press enter to find the sum, and then key in the division operation to find the mean or the average. So once you've added all your numbers and you get 68, you press your division operation and then 5, and that will give you 13.6, which is our mean in this case, okay? So another measure of the average is the median. And the median is the average value in a set of data. So in this particular example, we're being told that during a 7-hour period, a bookstore recorded the following number of sales. Find the median number of sales. So to find the median, you simply want to arrange your numbers from smallest to largest, okay? And then you would choose, so, okay, let's go back to the question here. An hour, let me zoom in. In the first hour, so let's change the question around to make it personal so that it can be easier for us. Okay, so let's say that you guys own a bookstore, okay? And during a 7-hour period, you recorded the number of sales that you made. So during the first hour, when you open up shop, you sold 43 books, okay? In the second hour, you sold 28. Excuse me. Third hour, you sold 24. In the fourth hour, you sold 36. 5th hour, you sold 32. In the 6th hour, you sold 37. And in the 7th hour, you sold 48. And now, let's say your store's regional manager calls you and they're like, well, hey, Jaleesa, or hey, France, what's the median number of sales that you made today? Okay, well, you're, I don't know, but you've written down all your sales, right? You've written down the number of sales per hour. So what do? You just go to your list of numbers and you rearrange them, starting from the lowest to the highest, right? So we can see that in this case, the lowest is 24, okay, followed by 28, then 32, 36, 37, 43, and 48, okay? So it's very simple. You just rearrange your numbers from smallest to largest, okay? And then you're going to count the number of values that you have, okay? In this case, we have 1, 2, 3, 4, 5, 6, 7. But let me go to the portion of the, okay, so we've rearranged our numbers from smallest to largest, okay? Then we're going to count the number of values that we have. So 1, 2, 3, 4, 5, 6, 7. Oh, this is great because it's an odd number, okay? 7 is an odd number. Your odd numbers are 1, 3, 5, 7, 9, right? Odd numbers are simply numbers that are only divisible by 1 and themselves, right? So like 3 can't be divided into 2, for example. You would, well, it can be, but you would get 1.5. You would get a remainder, right? So that's simply what an odd number is. And then your even numbers are your numbers that you can divide and without getting a remainder. So for example, 4 is an even number because when you divide 2 into 4, you get 2 and there's nothing left over, okay? So just know that they skip starting from 1, skip 2, 3, okay? 3, skip 4, 5, 5, skip 6, 7. So 1, 3, 5, 7, 9, on and on and on. Just keep skipping the next number. Those are your odd numbers. And then your even numbers, you're going to do the same thing, but you're going to start with 2. So 2, skip 3, 4, 4, skip 5, 6. So 2, 4, 6, 8, 10, 12, 14, on and on and on. Those are your even numbers, okay? So we've counted our values, 1, 2, 3, 4, 5, and we've decided that we have 7 numbers here. 7 is an odd number. And that's great because our median is going to be the number right in between. It's going to be the number right in the middle. So in this particular case, that's going to be 36. And if you covered 36 and counted the number of values you had on the left, you have exactly 3. 1, 2, 3, 24, 20, 24, 28, and 32, right? And then on the right, we have exactly 3, 37, 43, and 48. So you know that this is your central value or your median, okay? And that just means the number that's right in the middle of all your other numbers, okay? But it has to be in order. So if you had just, okay, in this example, it's actually 36 is right in the middle, but let's say it wasn't, okay? You would have selected the wrong number, okay? And in this particular example, let's say that we're advantageous and 36 happens to be right in the middle, but you always want to rearrange the numbers first, okay? And then the number that's right in the middle is going to be your central value, okay? Now, in the event that we had counted our values and we had an even number, then you would add the two numbers in the middle together and divide by 2. And we'll see an example of that coming up. But just know that for now, we found our median number because we've rearranged the numbers, the number of books that we sold per hour in increasing number. And then we've counted the number of books and we see that we have an odd number. And because we have an odd number, we would just cover the number in the middle, okay? And that number, to make sure that we are actually in the middle, you want to count the numbers on the left and the numbers on the right to make sure that they're equal. So we see that on the left-hand side, we have exactly 1, 2, 3 numbers, okay? And on the right-hand side, we have exactly 1, 2, 3 numbers. So we know that we're in the middle, right? And that's our answer. That's the middle number is the median, okay? And essentially, the median is the mean of two middle values. And it works out that this is the mean because we ordered our numbers in ascending order, okay? And this again is the central or a measure of central tendency or the mean, okay? So this is a different way of finding the mean. Instead of counting all these numbers and then dividing by 7, we just rearranged them and we chose the number that was right in the middle, okay? And in this case, that number is the median, that value that we found is the median. All right, so in this example, we're being told that Robert has the following test scores in his math class: 90, 72, 88, 94, 91, and 80. What is his median score? So let's say that France and Jaleesa, okay, just replace Robert's name with yours. And these are the scores that you made in math, okay, 90, 72, 88, 94, 91, and 80. And then I ask you, hey, France, hey, Jaleesa, what was your median score on your tests? Well, you can like, well, I don't know, but you know your scores, right? So it'll be pretty easy. What do? You first start by rearranging the numbers, starting from smallest to greatest. So in this case, let me zoom in. In this, rearranging our numbers, 70, 88, 90, 91, and 94. And then you want to count the number of values that you have. 1, 2, 3, 4, 5, 6. Well, 6 is an even number. Remember, when we start with 2, we skip over to 4, 6, 8, 10, 12. Those are our even numbers. So in this case, because like okay, let me put it this way. If we counted 1, 2, 3, okay, and I placed a pointer right here, and then we count on the right 90, 91, 94, that's exactly 3 values, right? So we have exactly 3 values on the left and exactly 3 values on the right. But right here where the pointer is, there's no value there. There's nothing there, right? But that's our midpoint. That's our middle point, but there's no number there. So how do we find that number? How do we find the number that should be here? Well, we just take the first number to the left, which is 88, and the first number to the right, which is 90. We add them together, and then we find the mean. And remember, how do we find the mean? It's always going to be the values that you have divided by the number of values, right? So we have 88 plus 90, and that's 2 values, right? 88 is 1, 90 is 2. Okay, so that's why we're dividing by 2, okay? So 88 plus 90 divided by 2, and you would find that the median score is 89. in this particular instance, okay? And it makes sense if you think about it, when you're counting 88, what comes after 88? 89, what comes after 89? 90, right? But we don't see that here. But we can find that number by adding these two together and then dividing by 2, okay? And that would be true of any value that would be any two values that would be in the center of an even numbered median, okay? Whatever number that you find would be the value that's right in between both numbers. In this case, it happens to be 89, which if we look mathematically, 89 is indeed right in between 88 and on the number line, right? Like if you imagine a number, not line, you would see 88. 89 is right in the middle, and then 90, okay? And that's what that median score or the median value is for this particular example as well, is 89. So again, what you want to remember when you're working with medians is that number one, you want to rearrange the scores that you have or the numbers that you have from smallest to largest. And then you want to count. If the number of scores that you have is odd, it's very easy because you just pick the number that's right in the middle. If the number of scores that you have is even, then you would add the two numbers in the middle, which in this case is 88 and 90. And if it helps you, we know that 88 and 90 is in the middle because if you draw a box around both numbers like it's done here, you can see that there's exactly two numbers on the left and there's exactly two numbers or two values on the right. So we know that these two numbers are right in the middle, right? Because if you picked 88, for example, and you said 88 was the median, it wouldn't be correct because you've got two numbers to the left of 88, and then to the right of 88, you've got 90, 91, and 94. That's three numbers, right? So you always want to make sure that think of it as like what's that thing that kids, a seesaw, like you want to make sure that it's balanced on both sides, right? So you've got exactly two numbers here on the left, you've got exactly two numbers here on the right, but because we have two numbers in our box, we want to add those two numbers up and then divide them by 2, okay? To get our median score. In this example, where we had exactly one number in our box, we didn't need to do anything, right? And we can check to the right, we have exactly 3 values, 24, 20, and 32. Excuse me, that's the left. To the left, we have exactly 3 values, and to the right, we have exactly 3 values, so we know that we're exactly in the middle, okay? And so just remember, when you have an odd number, you're always going to be in the middle. And when you have an even number, you want to add the two numbers in the middle, okay? And then divide by 2, okay? All right. So then the next measure is the mode. And this value just represents a number that occurs often in a set, in a data set. So a set of data could have more than one mode if several items occur the same number of times. So if each item of data occurs only once, then there's no mode, okay? And we'll see that in this example here. We're being told that 6 different weather stations recorded the following temperatures at 3 p.m. Okay, 45 degrees, 44 degrees, 45 degrees, 47 degrees, 46 degrees, and 45 degrees. What is the mode of the data? So let's say that you are the manager of 6 different weather stations. Okay, and you need to find out which what temperature occurred, what temperature that they record the most today. Okay, so you're the manager. You need to report to the regional manager, or you need to actually provide. Let's say you need to provide information to the local news station. Okay. So you call your first weather station and they tell you, oh, today at 3 p.m. we recorded a temperature of 45 degrees. Okay. Then you call your second weather station. They tell you that they recorded a temperature of 44 degrees, and on and on and on until you reached your 6th station, right? Now you need to figure out which of these temperatures are you going to tell the local news. So, and you've got 6 different weather stations measuring the weather, so that you can have the most accurate information possible. Okay. So in this particular instance, what you would do is select the temperature that was recorded the most times, right? And you can see that the first weather station recorded 45, so did the third, and so did the 6th, right? 45 was recorded by 3 different stations, right? So then you can call the news people and be like, well, today was 45 degrees, okay? And your reasoning or your rationale is that 3 different stations found the same answer, found the same temperature, okay? In terms, 3 different stations measured the same temperature, right? So if you're trying to find, determine the most accurate value out of 6, and you see 3 values pop up 3 different times, okay, and then different values for the remaining spots, okay, for the 4th, 5th, and 6th spots, you have other values, then you know that that value that pops up more than the others is the value that occurred most often, or it's the mode, okay? And so when the newscaster is presenting and they're saying, today's weather, we recorded heat index or temperature index of, if they tell you that the mode was 45 degrees, then you know that 45 degrees was the most recorded temperature from a range of temperature recordings, but they'll let you know that it was the mode. If we were trying to find the median, well, we would have to rearrange this number. So we would write down 44 first, then we would write down 45 3 times, because we see that it occurs 45 occurs 3 times, and then 46, and then 47. And then we would go to the middle 2 values, because 6 is what, an even number. We would go to the middle 2 values and we would divide by 2, right? We would add the middle 2 values together and divide by 2, and that would give us our median. And I remember mode because there's an O in mode, and there's also an O in often. So it's the number that occurs most often, which in this case is 45. We see it occurred 3 times, okay? So 3 different ways of measuring central tendency, but just know that each representation is approached differently. So again, if you're looking for the mean, you would add all your scores and then divide by the number of scores. If you're looking for the median, you need to start by rearranging your numbers and then count your numbers. If you have odd numbers, your median is the number that's right in the middle. And if you have even numbers, your median is the 2 scores in the middle added together and then divided by 2, okay? And then for the mode, you want to find the number that occurs most often, okay? In this particular case, we've seen 45 3 times, so 45 is the mode, Okay. So again, I would make a note, you know, kind of a short definition of each measure, and then knowing that if the question is asking you for the mean, you know, that like in this particular instance, we've seen 6 numbers, but 3 different questions can be asked of you based on these 6 numbers. Okay, a question can ask you, find the mean, and then the next question could be find the median, and then the next question could be find the mode of these same numbers. Okay, and you know that you need to approach the same question 3 different ways. All right. And I just highlighted again the mean. You would add the scores that you have and divide it by the number of values. The median, you start by rearranging the numbers from smallest to largest. Okay, if you have an odd number, your median is the value right in between. If you have an even number, your median is your 2 values in between divided by 2. Okay. And then if you're being asked for the mode, you simply look for the number that occurs most often, okay? And I think this is actually it. Do you guys have any questions?
No, I
Okay,
don't.
That's okay.
okay,
Yep,
Okay.
we'll do. I could do that.
okay. All right, cool.
Mhm.
All right, so yeah, that's it. I guess I'll see you guys on Thursday.
All right. See you Thursday.
Yeah, have a good weekend. Have a good evening, I mean.
You
All
too.
right.
All right.
Bye.
Bye.
Bye.